Today we're going to look at vector addition. We're going to add these two vectors together. Today we're going to look at vector addition and the steps required to add multiple vectors together. Now we're just going to do two, but you could use these same steps to add multiple, like 3, 4, 5, and as many vectors as you want. So the first step we're going to do is we're going to draw a diagram. So I have these two vectors, 28 meters per second at 14 degrees west of north and 12 meters per second at 32 degrees south of west. So what I'm going to do first, I'm going to draw just a general picture, a graphical addition, if you will, just to see what I should end up with. So I start out with coordinate system. I draw my first vector. So this one is 14 degrees to the west side of north. So I start at north and I rotate 14 degrees and I go 28 meters. So there's my 14 degrees to the west of north and has a magnitude of 28 meters per second. I draw my second vector. Now I draw it right off the end of it. That's how they add them together, one right after another. And when I draw my second vector, it's going to be 32 degrees to the south of west. So I start at west and I rotate to the south 32 degrees. And I draw it about 12. So that one is 12 meters per second at 32 degrees south of west. And the end result is I want this vector. This is the resultant vector. It'll have a magnitude represented by the length and a direction pointed in generally my northwest. So I just want to use that as a check when we get to the end. All right. So now, our first step is we need to get the components of each of these vectors. So what I'm going to do is I'm going to draw each vector independently, and then I'm going to find their components. So we start with this first one. Okay. So very similar to how we started our main diagram. So we go 28 meters per second at 14 degrees. Now to find the components, I'm essentially finding out how much in the vertical or the y direction, how much in the x does it go. So I want to figure out what is this component, which is my y component, and what is this, my x component. Now notice when I'm drawing these, I am putting arrows on these so that I know the direction of them. Because all trigonometry is going to do for us is find magnitudes, the sizes of the sides, but the arrows are going to tell me the direction. My other one, I'm going to draw that one as well. I'm going to draw it down here, though. I'm going to draw them separately. It makes it a little cleaner. So this one is 12 meters per second at 32 degrees. I'm going to find the x component and the y component. Again, notice the arrows. Those are telling me directions. All right, so I'm going to find my x component and get a number, my y component, get a number. Find my x component, get a number, my y component, get a number. Okay. So, quick review of trigonometry for you. So, this side is adjacent to the angle, my x side is opposite, and the 28 is my hypotenuse. So to find the adjacent side, what we're going to do is we're going to go ahead and use cosine. So the cosine of 14 is going to be the adjacent side divided by the hypotenuse, so y divided by 28. And so if I multiply the 28 over, I get y is equal to 28 cosine of 14. And I double check my direction. So it's pointing up, so I need a positive. Check. Next, my x, it's opposite, so I'm going to use the sine. So the sine of 14 is equal to the opposite divided by the hypotenuse. Multiply the 28 over, so I have 28 sine of 14. And then I got to add my direction, so it's pointing to the left, so I need a negative sign there. Don't forget to put those directions on. Do the same thing down here, so adjacent sides use cosine. So this one is 12 cosine of 32. Opposites use sine, so this one is 12 sine of 32. And I check my directions. Left for the x is a negative, and down for the y is a negative. Now that I have my components, I haven't typed these in my calculator yet. The next step after you get the components, and if you had more than two, you would just do this for a third one. Do it for a fourth one. Find the components. Next, you're going to add up all of the x components and add up all of the y components. So add them together. So I have negative 28 sine of 14 plus negative 12 cosine of 32. And in the y direction, I have 28 cosine of 14 plus negative 12 sine of 32. Now, when you put that in your calculator, you end up with about negative 17 meters per second and 21 meters per second. Store those numbers in your calculator. You need those to be as exact as possible. Don't round them as much as I have seen here. I have them stored on my calculator. Okay? The next step is you're going to take these two components, the x and the y, and you're going to combine them. So essentially the opposite of what we did here. We took a magnitude and a direction, and we resolved it into our components. Now we're going to take components and we're going to create a magnitude and a direction. So what we do is we start by drawing those components. So I'm going to draw the 17 first, and it's to the left because it's negative, and that's in my x direction. And then the 21, oops, that's in the positive direction. Let me try that again. So I'm going to have my 17 in the negative direction and my 21 in the positive direction. And I want to find this magnitude and the angle that's associated with it. So in order to find the magnitude, we're going to use the Pythagorean theorem. So this side over here is going to be the square root of 21 squared plus 17 squared. Now remember, be sure to have these stored. Don't just use those rounded numbers. Okay? To find the angle, all right, so I know the adjacent and the opposite sides, so I'm going to use the tangent. So I'm able to say that the tangent of the angle is opposite, 21, divided by adjacent, 17. And so my angle is going to be the inverse tangent of 21 divided by 17. Now, yes, you have x stored as a negative. It didn't matter when you squared it, but here it does. So you might want to put a negative in front of it so you get a positive angle out. Otherwise, you might get a negative angle. So when I find these two values, I get 27 meters per second here. I get an angle of 51 degrees. The last step is you got to put it all together so it looks like what we started with, a magnitude with a direction. It's more than just an angle. We have to have a reference. So I put these two together and I get 27 meters per second at 51 degrees. And that's telling me that my vector, this red line, is 51 degrees on the north side of west. So to the north of west. This is vector addition. Follow those steps. Just to reiterate them, 1, draw a picture. Whether it's this picture or independently, draw the diagrams. 2, resolve it into components. Find the components of each vector independently. 3rd, add up those values. Find the x sum and the y sum. 4th, you're going to find a magnitude. And 5th, you're going to find a direction. Then put those two together. And you have your vector addition.